Hi everybody, this is Mr. Murphy, and I'm going to take you through our limits day 3, which is really just a practice day for you guys to work on everything you've done up to this point. So that being said, we'll go through a couple of the techniques, just make sure that everybody understands everything, and do a few of the problems here or there, but I'm going to leave a lot of them blank just for you guys to work on, and then you can access a key to check your work with them. So we'll do a few from each type of different problem just to make sure that we really have this stuff down. So over the course of the last couple of days, you have hopefully learned that the limit is what we're using to evaluate a function as the function approaches a certain number. So that keyword approaches, we've been using over and over again. That's very important when we're referring to limits. So a couple of the techniques that you guys have learned in the first 2 days of limits here. If you're evaluating a limit, f of x over g of x, just meaning there's a numerator and denominator there, first step is our quotient rule. So what that basically means, this is obviously kind of confusing when you look at it written out like this. If they both exist and g of x doesn't equal 0, you see the rule down there. What this really means is if you can plug it in and get a number, do it. So obviously a number, you're not getting 0 over 0. You're not getting a number over 0. You're going to get, a 1/2 of 5. When we say to plug it in, what you're plugging in is the number that we're evaluating underneath. So if this is saying like as x approaches 5, 5 is the number that you're plugging in for the x values. If you're able to get, some kind of a real number out of that aside from 0 over 0 or a number over 0, that's your answer right there, and it's that simple. So always as a first step, I would say check this first quotient rule, see if you can just plug in the number. If you plug it in and get something different with the zeros, that kind of directs you into one of these other categories here. So number 2 is saying if you plug in that number that you're approaching and you get 0 divided by 0, right? So if you get 0 over 0 after you plug in, you're going to want to do one of two things. You're going to want to see if you can factor it. Once you factor it, you'll hopefully be able to cross things out, get it to lowest terms. If it's not factorable, if it involves a square root, you're going to want to multiply by the conjugate. Again, that's going to allow you to simplify things, cross things out. Once simplified, so we got one simplified, I'm going to say plug in again. So at this point, you would then plug in the number again. Hopefully now you're no longer getting 0 over 0. You're going to get a number. It's going to kind of fit into what we said with the quotient rule. So that's kind of your second option. The third one here, this is saying that the numerator is a number. So you basically, when you plug in the number, you're getting a number divided by 0. What you want to do on these, so it either doesn't exist or it goes to positive or negative infinity. The way that you tell is, so I'll say can tell by looking at the graph. So your work for this could be you could show that it's a number over 0 and then just a really rough sketch of a graph, and like there's always going to be an asymptote involved. So let's say we got this going on and the graph is going like that and like that, let's just say. You can see as we're approaching, let's say this is an x value of 2. As we're approaching that x value of 2, from the right it's going to a positive infinity, from the left negative infinity. This would be like a does not exist type of problem. If they're both going to the same place, then you'd get an answer for that one. The last rule here, if x is approaching infinity or negative infinity, so that's saying you're talking about the limit as x approaches positive or negative infinity. To evaluate that, you can divide by the highest power of x in the denominator, but really you can just, I'll say, can use horizontal asymptote rules. Really, it's all based, I'm going to say, all based on degree of numerator versus denominator. And we'll do a couple of those ones together just to make sure that everybody is aware. On the bottom here, two really important things. Anytime you have a number divided by infinity, the denominator is so much larger that basically just approaches 0. Anytime you have infinity divided by a number, that is going to be infinity. So that's kind of important to keep in mind as we go. So like I said, we'll do a couple of these as as a group here, and then I'm going to leave a bunch of them blank just for you guys to practice and work on your own. So we want to evaluate the limit as x approaches 5 of this function here. So first step is always just to try and plug in the actual number. So if we plug in 5, we get 25 minus 5 minus 20. We can see that we're getting 0 divided by 0. So we want to use our technique of trying to factor both parts. So we got our limit as x approaches 5. If we factor this, our numerator is going to be what? We're going to have x plus 4 times x minus 5 all over x minus 5. The x minus 5s cancel out, right? So we're just left with the x plus 4. Now we plug that in, and we get 5 plus 4, and our answer is 9. So after you simplify it, you're just going to reevaluate it by plugging that number back in. With number 2 here, if we try and plug in the 7, we got square root of 9, so 3 minus 3. So again, we're seeing 0 over 0. We have the radical, so this case we're going to try and multiply by our conjugate. So instead of minus 3, we're going to multiply top and bottom by square root of x plus 2 plus 3. So in our numerator, what's nice and easy about this is you're foiling it. Seems complex, but it's really just the first squared plus or minus the last squared. The outside and inside cancel each other out. So we've got the x plus 2 after we square when we do square root of x plus 2 times square root of x plus 2, and then it's just going to be minus 9 up there. In our denominator, what I want you to do is on this stuff, never actually distribute it through. So you're going to have the x minus 7 times parentheses square root of x plus 2 plus 3. So why are we not doing that? If we look at this right here, this is going to simplify to x minus 7. It will pretty much always simplify to whatever that original value is. So when those cross out, what are we left with here? We're left with a 1 over square root of x plus 2 plus 3. If we now try and plug that 7 in, right, we're going to get the 1 divided by, it'd be square root of 9, so 3 plus 3, so we get 1 over 6, which is our final answer there. So key thing on that one is just this step right here, not distributing through in your denominator. It will always cancel out nicely on those if that's the case. All right, number 3. Let's just do this one, then we'll look for something new here. First step, try and plug in the 3. So if we do that, what do we get? We get 3 to the 3rd, so we're at 27 minus 18 plus 2 all over. We'd have 9 plus 6 minus 3. If we simplify all that out, 27 minus 18 plus 2 is just 11 divided by 15 minus 3, so 11 divided by 12. This is what I was talking about before. If you plug in that number and you get something like 11 over 12, that's it. You don't have to do anything else. That's your answer right there. So it's really just identifying first by trying to plug it in, which route we want to take with these, and then going from there. All right, I think the rest of this page is kind of similar type stuff to those 3 that we just went over. So I'm gonna try and find something new here for us. So let's look at number 10. We'll do this one. Limit of x to the 3rd minus 7x over x to the 3rd as x approaches 0. So if we try and plug this in, we are getting 0 over 0, right? So this one is try and factor it, right? So if we factor the x to the 3rd minus 7x, we get x times, we could have x squared minus 7. This is over x to the 3rd. So what's going to simplify? Now we'll cross out the x, cross out the 3rd and make it a squared. So if I just rewrite this, we've got x squared minus 7 over x squared. At this point in the year, nobody should be crossing out those x squareds. We know when it's addition, subtraction, you can't just cross stuff out like that. This is, so I'm being a little bit lazy, but we're doing the limit as x approaches 0 of all of that. If we try and plug in the 0 now we're getting negative 7 divided by 0. So we're saying this at the start, if you're dividing by 0, this is where you would want to look at the graph. So if I look at the graph on this, and by looking at the graph, you can just put this value right here, just right into your y equals on your calculator, right? So if we look at the graph of this, I think we had, there's definitely some asymptotes going on. Really just a rough sketch of this. It should be looking, you could type it into the calculator to look at it. It's not asking you to do this out in your, by hand necessarily. You've got your calculators. So as we're approaching 0, we got to look from the left side. It's going off to negative infinity. From the right side, it's going to negative infinity. Because it's going to the same place, that is our solution for this. And we just get negative infinity as our answer. The one I did on the first page, they were going to different spots. So obviously that was why it did not exist. If they're going to the same place, we can say that that does exist for that one. So that's what we're looking at when we need to use the graph. Let's see. Let's jump down to 13 and 14. So these are as we're going to infinity or negative infinity. So the key thing with this, and I said this before, it's all just based on the degree. So on the first page, we said that anytime that we had a number divided by infinity, it equaled 0. Anytime we had infinity divided by a number, it was infinity. So if you think about this, because the degree is larger in your denominator, if we're plugging infinity into that spot, we're going to end up with a number divided by infinity, and this is just going to equal 0, right? The 100, the plus 5, those mean nothing when you're squaring infinity. That number in your denominator is getting so large that just is going to be approaching 0. Same thing with this. We're really just focusing on our degree. So x over 3x, the 7 and the 5 mean nothing as we approach negative infinity. The numbers get so large. So what this is approaching is you really have the degree the same. So it's just whatever that ratio is on that one. So it'll be 1/3. These are really, really quick. The ones that as you're approaching infinity, those are the ones we should be happy to see. If we look at this one, so again, we see this, so we know we're focusing on that. Look at the degree. The degree is the same, so it just equals 7 over 2. All right? Look again, degree. Degree is larger in the denominator, so that's 0. The times where it would be infinity would be if it was switched. If you're saying the limit as x approaches infinity and you had x to the third over x squared and it doesn't really matter what the rest is, this is where this is going to approach infinity as opposed to 0 or some number. So those are really the only 3 rules. That's why I was saying it's the same as your rules that you should hopefully remember from your rational functions unit with your horizontal asymptotes. Lastly, let's just look at a couple of the graphs, just because these ones, so they're just giving you the graph. These, once you get the hang of them, are much simpler because you don't need to worry about factoring, multiplying by the conjugate, anything like that. It's really just visual, but obviously you need to understand what they're asking in order to really get these. So we got our function on the right here for number 17. They're saying as x approaches 1 with that little negative up there. So when we're looking at this, that little negative is saying that we're approaching from the left-hand side. So we're coming across, obviously 1, we can see where our x value of 1, I'll kind of just draw it in, is right here. As we're approaching that from the left-hand side, we're looking at this value right here. So what are we getting closer and closer to? We're getting closer and closer to a value of 2. Right now you might be saying, all right, there's an open circle there. That doesn't make sense. That's why we keep using the term approaching, and it's not at that actual spot. That's what we'll see at the bottom there when it says f of 1. That's talking about where exactly is it as at an x value of 1. This is saying as we're approaching 1 from our left-hand side, we're getting closer and closer to a value of 2. The difference with part B is it's saying 1 from the right-hand side. So with part B, we'll just change our kind of color so we can see it. So for part B, this is now from our right-hand side. So we're looking at this part. As we're coming up here, we're getting closer and closer to a y value of 4. When we look at C, there's no plus or minus associated at all. So that means that you need to take both parts A and B into consideration when you're determining your answer. Because these are going to 2 different places, this does not exist. The only way that this would ever exist would be if these 2 parts right here were the same. So if they were both approaching 2, you would say that the answer was 2. They were going to different places, so it does not exist. Lastly, f of 1. So this is no longer talking about as it approaches. This is saying just add an x value of 1. Where is your y value? So add an x value of 1. That's that point right at 3 that we see there. So it's not talking about coming from either direction or anything like that. It's just saying when x equals 1, where's your function? Your function's at 3 on this one. So hopefully that makes sense with all the kind of different values there. Maybe quickly, just because I know the graphs, like I said, it's very visual, and you either get it quickly or you don't. Let's just do 18 altogether really quickly as well here. So we got -2, and we're approaching it with that negative sign, saying from the left-hand side. So as I'm kind of going across, I'm saying from my left, you can see that this is going off to negative infinity. As we're approaching -2 from the right side, this is over here now. So now this is going up, right? So that's going to be positive infinity. So if it just says -2 with no plus or minus, these are going to two different spots right here. So that means that the solution for that would be does not exist. All right, I left a bunch of problems blank at the beginning of this. So I would say go back and work on those. Answer keys, I'm sure, will be posted by your classroom teachers. They can also let you know what your homework's going to be for tonight, whether they give you exit slip that will be provided, or if they just want you to take pictures of your homework, they can tell you what they want you to do for that. So hopefully everything made sense and things are coming together with our limits here, and have a good